Hi everyone. In this video, I'll give you a quick introduction on how to work with Blendshape rigs in Wrap4D. As you may know, our software is often used to create blend shapes from 3D scans of actor expressions. Lately, we've also been doing a lot of Blendshape work for rigging. What we found out is that many common operations for Blendshape rigs, such as splitting a rig left and right or fitting a rig into a target shape, do not have an easy solution on the market. That's why we decided to add a few simple tools to help working with Blendshape rigs in Wrap4D. Let me explain how it works. Imagine a simple Blendshape rig with the neutral expression and a few other blend shapes. We have three hero expressions: blink, jaw open, and funneler. Additionally, there's a corrective shape that activates when jaw open and funneler are both activated simultaneously. This is a first order corrective. This is a very basic version of the rig. We can save every mesh of this rig as an OBJ file into a folder. We follow a simple naming convention. For example, jaw open-funneler indicates a first order corrective between the jaw open and funneler expressions, and is activated when both are triggered together. We can have a second order, third order, and higher order correctives, but let's keep it simple for now. Let's see how we can load this rig into Wrap4D. First, I have a neutral expression here. And then I'll create a load BlendRig node. Now, I need to select my set of blend shapes. I'm selecting everything except for the neutral shape. Next, we create a pose BlendRig node. This node allows us to modify the rig's controls. In the Visual Editor tab, I'll click Controls from Reference BlendRig. This will automatically create all the hero shape controls and incorporate all the correctives with proper logic. We can activate our eye blink expression, the funnel expression, and when we activate both funnel and jaw open expressions, our corrective shape is triggered automatically. Using the pose BlendRig node is an easy way to make sure that the rig logic works correctly. Rig blend shapes are often created by scanning expressions of a real person, and most of the time, those scanned expressions are symmetrical. Let's see how we can split our blink expression into a left and a right blink so that we're able to control them separately, or to fine-tune the weight of the funnel for the left and right side individually. To do this, we'll create a split BlendRig node. We plug in our original Blendshape rig, and we use a vertex mask to define how to split it. Alright, let's create this. I'll use the Select Polygons node. I'm going to select a polygon loop that splits the face vertically. To do that, I click on a single polygon, then holding the Shift key, I double-click on a polygon next to it. I'll hide it, and double-click on the left part of the face. Then I use a polygon selection to vertex mask node, plugging in my neutral expression and the selection. Now we have a vertex mask selecting half of the face. Next, we'll smooth the vertex mask with the Modify Vertex Mask node. Let's set the mode to Laplacian smoothing. In the Laplacian smoothing tab, I'm adjusting the iterations to 20 and the neighbors to 2 for a smooth mask. We plug this mask into our split BlendRig node. Updating the pose BlendRig, we now have controls for the left and right eyes separately. And we can trigger the funnel from either side. Let's reset controls. However, if we trigger jaw open, it only affects half the face. But we want the jaw open controller to open the entire jaw simultaneously. To do that, we can exclude the jaw open expression from splitting in the split BlendRig node. In the split BlendRig node parameters, I can type in jaw open in the exclude hero shapes field. After updating the pose BlendRig again, we get a single jaw open slider. Now we can control the funnel expression from each side separately. But what if we want to individually control the lower and upper lip activation in the funnel expression? For this, we can split the blend shape into top and bottom parts. We use another split BlendRig node and provide a different mask for splitting the top and bottom parts. Let's reconnect the inputs. We can copy this part of the network and paste it using Ctrl-Shift-V. Let's select the loop, splitting the top and bottom parts. Let me hide these polygons and select the bottom part. We adjust smoothing parameters, setting neighbors to 1 for a smooth face splitting mask. We'll pass this mask into the split BlendRig node. Let's adjust the suffixes. The selected part gets suffix B, meaning bottom, and the non-selected part gets suffix T, meaning top. And after updating the pose BlendRig, all shapes split into top and bottom. Now we don't want to split certain expressions like jaw open or blink. In that case, we can go to the split BlendRig node and specify only the blend shapes that we would like to include. In this case, funnel. Now the rig is correct. We can control the top or bottom lip for the funneler separately, while the jaw open and eye blinks remain non-splitted. Alright, so that was just a mock example. This time, let's test a real rig with 130 expressions. I'm going to load this into the load BlendRig node. Let's select a complete set of blend shapes, excluding the neutral expression. Let's wait until it loads the entire rig. In the post BlendRig, we'll click Controls from Reference BlendRig and see all the shapes split for us. Since this rig contains more shapes, let me adjust the included and excluded blend shape lists accordingly for my split BlendRig nodes. I'm going to copy and paste a list of blend shapes here, and we'll do the same for the second split BlendRig node. Now we have our complete rig with hundreds of blend shapes. To easily find a specific expression, we can start typing its name into the filter box. Our rig contains expressions like lips left and lips right. Technically, we can trigger both expressions at the same time and break the rig. To prevent this, we can combine them into a single slider. We do this by loading a rig config file into the load BlendRig node. The rig config is a simple JSON file. This file defines rules to combine left and right suffixes into a single suffix called side, the up and down suffix into vertical, and the in and out suffixes into in-out. Updating the pose BlendRig, we now have a lip side control with a single slider going from -1 to 1. We also have jaw expressions like jaw side, which also works well. We can open the jaw and work with jaw side simultaneously. After all these modifications, we can use a Save BlendRig node to save our modified rig to disk. I'll create a folder called Rig Export. Let's copy the same path for Blendshape folder name parameter. I'll select the file format as ply, as it takes much less disk space. We can either save all the blend shapes as final target meshes, neutral with Blendshape deltas, or just Blendshape deltas. We'll click Compute Current Frame, and it will save all our blend shapes to the folder. This might take some time. If you check the folder, you'll see it saved all the hero shapes and correctives in the proper rig structure, with almost 287 expressions processed in minutes. Now that we have a fully functional rig, let me show you how we can fit the rig controls into a 4D animation sequence. I'll create a Load Vertices node, plug in my neutral expression, and select a real 4D animation sequence from the HMC. I'm going to load it as a file sequence. By scrolling the timeline, we can see the loaded animation. Now we can use a Fit BlendRig node to fit the rig into each animation frame. The first input is a Blendshape rig, and the second input is the 4D animation. For now, let's turn off the Fit Eyes using Transformations option and click Compute. The computation takes some time. To see the result, we'll use a BlendRig to Geometry node. We can create a Transform node and move the target geometry to the side. As you can see, the fitting did a pretty good job. Now, if you compare the models closely, you can see that there are still differences between the Blendshape rig and the target shape. That happens because the set of blend shapes in the rig is not as expressive as the real face and can't cover all possible expressions. But the fade result is a good starting point for a lot of applications. Let's find another shape and run the fitting again. After some time, it fits our Blendshape rig. The Fit BlendRig node has many advanced options, like providing explicit controls over gaze direction. For example, it helps reduce ambiguity between a look down and a blink expression. The node also has an option to ensure the lip and eye contours are closed whenever they are closed on the 4D sequence. I'll explain these as well as other features more in depth in another video. Now, during fitting, you may lose some fidelity because a Blendshape rig just isn't as flexible as a human face, but again, it's a good starting point for many applications. You can run this fitting on all frames in parallel using multiple machines or run it on a single machine in multiple processes. You can save the result using the Save BlendRig Controls node. Let's provide a folder name. Now we can click Compute Frame Range to process the frames on the sequence in parallel. After the computation of all the frames is finished, we'll have a sequence of JSON files corresponding to each frame stored in the folder. Now, I've already run the computation, so I can use a Load BlendRig Controls node to load them into my project. Let me remove the Fit BlendRig node. I'm going to load this file as a sequence. Now it loads the corresponding control values for each frame. Finally, I convert the rig's current state into geometry. On the left is our 4D animation, on the right is the rig animation. And as you can see, it does a pretty good job fitting each expression in our sequence. Please note that the result of the rig fitting for every frame is simply a JSON file that contains a dictionary of values for every rig control, and those sets of values can be imported into your animation software later. You can go further, like running the rig fitting in 2 stages and smoothing the computed controls with the special node to produce more accurate rig fitting results. Again, this and other features I'll explain in another video. You can find a sample project for this rig fitting and a sample 4D sequence in the Gallery tab of Wrap4D. That's it for this tutorial. I hope you liked it, and stay tuned for future updates.